Good morning, everybody. Just acutely aware of the amount of red on the screen, so if you feel hostility, keep it for Nigel, probably later on today. So today for us is about taking you through some of the steps we went through to implement Puppet at RMIT. Just before I start, just to get a context for the audience, how many of you guys are operations and how many are developers? So ops people, just put your hands up. Okay, and the rest of you are developers, okay, so there's a good mix. So I'm the Unix team lead and Nigel is a senior developer, so I'll be talking about the ops stuff. I don't really care about the Windows stuff, so you won't hear me talk about it, although Nigel does care a little bit. He'll talk to you about that as well. There were a couple of other people that were due to be here today to talk to you about some of the stuff we're doing in AWS, but they're not here. So unfortunately, we can talk about it in much degree of detail that I would have liked. So for us today, essentially, we'll talk about what Puppet is for us as an infrastructure tool and as an applications tool, how we started with Puppet, why there was some hesitance at first to adopt Puppet, the iterations we went through. We actually went through 4 or 5 iterations before we got into Puppet Enterprise. I'll also speak about our evolution, our adoption rates, metrics you should be looking at. By all means, this is not a long-way conversation, so if you have input for us and you see mistakes we're making, feel free to contribute. Feel free to tell us anything that you think would be valuable for us. A couple of other things. The platforms we'll look at, we'll go through that. The platforms we manage. We're not special. We're not beautiful and unique, as Willie said this morning. We do have a large footprint. We do have an eclectic footprint, so we look after a whole ton of stuff. Just jump on the next slide. So for you, in essence, try and get what you can out of the conversation. Try and see and learn from the mistakes that we make. We made quite a few. There's some very, very glaring ones. Sometimes it will be obvious, sometimes it won't be so much. And if you feel that we have made a mistake that you can avoid, I'm happy to give you contact details to people that you can talk to for your implementation. I have to facilitate a conversation. Feel free to approach us. So I'll go through our environment and before we stick on the table. We have a very, very large ecosystem. I'll start with the top one, way down the bottom. We have a lot of Spark gear. The Spark gear hosts the enterprise stuff. Puppet is on Spark at the moment. It wasn't originally. We have a lot of x86 commodity stuff, HP, Dell, etc., etc. The Spark gear is mostly N9000 T-series, T4, T5, T6, Solaris 10, Solaris 11. If you're using Solaris 9, that's bad. Probably shouldn't be using Solaris 9. Our Linux footprint is Red Hat, Red Hat Enterprise, 5 and 6. We're moving to 7, but we're not quite ready yet. Our application footprint, Java, SAP, PeopleSoft. So out of curiosity, how many people are actually using PeopleSoft at the moment? Yeah, there's not many of us. What about SAP? Yeah, similarly, not many of us. Puppet isn't quite managing those tool sets yet. It is managing the platform that hosts those tool sets, but there are some unique challenges we can talk about later for SAP and PeopleSoft, particularly when it comes to managing the app stack. Oracle and MySQL, not really managed using Puppet. Cloud control at the moment for Oracle. MySQL is basically hand-built. Not very pretty, but we'll get there. And our data centers, this is the interesting part I wanted to talk to you about later, is on-premise and AWS. At the moment, we have a very large footprint of Puppet being deployed into AWS. We started with free, we've gone to enterprise, I'll explain to you why later. But the 2 people that are actually deploying them, that produce a couple of slides and I'll take you through it. It's quite interesting, the AWS stuff. Lastly, today's not actually a sales pitch. Puppet Enterprise was good for us. You can decide whether or not it was good for you. Feel free to ask us why we made the change in our cost. I'm happy to share everything that we have. But we felt Enterprise was the way to go because just the ease of the implementation. So this is our pre-enterprise environment. So our first implementation, we actually had 4 nodes managed by open source Puppet, and all it was doing was DNS and NTP. It was 4 research servers actually. which is quite interesting because research is one of the least managed areas that we have. The other thing is, about 30% of my staff, and I'll talk to you about this as we progress, you need really to have staff input, you need to have staff drive, they need to be interested, and there needs to be a desire to use the tool. Because we used CF Engine previously, and it fell to pieces after the people that were interested left. So quite an important thing, you have to consider staff uptake. But at the start, we basically had open source, 4 nodes, and it sat quietly for about 8 months. Then, one of my staff members, David Marshall, I'll use his name, deployed enterprise test, and we had 10 nodes. And we figured out the amount of time that we saved from hooking up basically pre-enterprise, because we get all the tools there, collective, et cetera, and the live management stuff. People started to become more interested. So we kind of hit critical mass at 1.5, and at the same time, there was an implementation, or rather a project, that came around and said, hey, look, we need to do inventory because we need to patch. And we kind of worked out a deal that, hey, if you pay for Puppet, we'll start doing patching for you. We originally purchased, I think it was 500 nodes. It was about 500 nodes. And we started deployment of Puppet. Yeah, also, we didn't manage much other than DNS-TP. It was basically for inventory management that we were using Puppet in version 1.5. So our first enterprise installation, it is very, very ugly, or it was very, very ugly. One of the scariest things now that I look at it, we had dev test and prod, we had no workflow, and we had a lot of stuff interested, which made it all that more dangerous. But if you have a look at it, it's quite an easy install. It was just run the installer on Red Hat 5.6, install it, let it go, let it do its thing. There were some really good things that came out of this, even though it looks very bad. We had complete inventory. We had users managed from Puppet. We had AD delegation for PAM, but our UIDs and GGIDs were still managed by Puppet. Sorry, GUIDs. The other thing to note is when you're training your staff up, don't send them all at the same time. Do it in dribs and drabs, because eventually what will happen is people who are at the top end of the spectrum will drag people who are behind up to where they are. Invariably, you want the training to be scattered. If you have questions, feel free to put your hand up. So, I'll start with the bad. No workflow. That's a terrible thing. You'll hear people talk about workflow all the time. It is one of the most important things that you will have to deal with. Promotion of dev test into prod is ultimately one of the biggest problems you'll solve. Just to go back, for us, this is the Mount Everest of problems. It was the biggest problem we had to solve. Because people making changes all the time and breaking things. But luckily for us, because we had a very small management footprint, DNS, NTP, and AD, people really couldn't break all that much. So we got lucky. We got really lucky. No testing, no peer review, which basically means people can do what they want. That's not great either. So insofar as good, we had SUDOs, accounts, auth, and inventory, all within live management. Very easy to get done, as opposed to before, very manual. So you need to grab some water. So for implementation 3, we actually separated dev test from prod. I think it took us a really long time to get here, which was a problem, because we spent a lot of time trying to make it perfect. This is not a mistake you should make. Just pick your biggest problem and try and solve it immediately. I think it took us 8 months from, just back from here to here, which is a long time. Basically what happened is we sat down and we started planning and just trying to fix iterations over every week. And then once we knuckled down, we basically said, no, we've got to separate dev test and prod if we want to make progress, and we did. It's very, very primitive. The promotion process is basically an rsync. We've also created an artificial situation where we have 2 different repos. You're also looking at 2 master monoliths there. So basically, we don't have inventory in one place. If we need to do inventory, we need to go to 2 places. If we need to do patching, etc., we need to go to 2 places. But it's a lot better than before.
So you're with the environment, you're not using separate environments on one master?
No, we're not. These are two monolith masters. Sorry, so the question was, we're not using two environments on the one master, and the answer is no, we're not. This is actually two different monolith masters. We found it the easiest way to separate dev, test, and prod. In Puppet 4 that will change, but yeah, that'll be later. Yeah. The other good thing is, peer review is now possible. So before you promote changes, somebody will actually go through it. Our promotion process, and I'll go through it in a second, is basically sits in dev test for a week. You brief your staff on the changes on Thursday morning. Never do changes on a Friday. Everyone's people's weekends. They get upset. Then you push it out to production. If you compare this to our original workflow, we pushed right out to production, which is never good. Right? You'll break stuff. The other thing is peer review and testing. Inherently, you need a degree of testing because at the start, you'll only do ops, like only platform stuff. Later on, when the apps guys come on board, you'll have more issues. The other thing is, every Thursday, we have a habit of talking about the changes that goes through dev, test, and prod. I don't know how you're going to do it in your culture, but we typically do that when we stand up. Stand up is a great place to do it because everybody's there. Right, so I'll take you through what we actually did over the last 2 years. One of the things I didn't mention deliberately at the start was it's taken us 2 years to get here. So just to give you an idea of growth, when we first started, we had 10 in April 2012. A year later, we had 300 and something odd nodes. Within the end of that year, we'd run out of licenses, but we had to get more. We're up to about 686. I'm expecting maybe another 240 odd once we hit AWS. One very important thing to look at is our staff headcount is static. In fact, I've lost a guy. So now that we've got Puppet, our management overhead is about that big. It's not, once you're there, managing your stuff is not a lot. One of the other interesting things is, up to October 2013, our workflow wasn't really set. What would have happened was, we basically did promotion within the team only, or without advertising. After 2013, we started working on our workflow, and we refined our processes, and we found adoption to start a lot faster than it used to be. We just started eating up licenses left, right, and center. So people who are actually management, I've got a slide to help you out. So to support your growth, there's a really good article, Predictors of DevOps Performance. One of those, 3 of those 5 things are actually captured by your workflow. Have a read of the article, it's very good. I won't go through it here because it's publicly available. The other thing you need to do is, you need to remove fear of failure. I'll just go back to the other 2 slides for a second. Here, if you fail, you break everything. Here, if you fail, you only break dev and test. People are more willing to experiment in this kind of environment than they are in a full prod environment. So keep that in mind when you're doing your implementation, because this really affected adoption for us. The other things to consider are mean time to recover, mean time between failures. It was mentioned at the start, but one of the things, just another quick poll, how many of you do DR testing on a regular basis? Yeah, so what you should do is time your DR test pre-Puppet and then time them post-Puppet. We had a 10-fold increase. So one of our DR tests that we did is usually for high availability infrastructure, let's say DNS, NTP. Over the course of a weekend, after Puppet was implemented, we went from an 8-hour turnaround to an 8-minute turnaround. So there are really good things to be had. The other metrics you should be looking at is the number of git commits and your promotions to production. I think the number we used before was 30-fold increase. We're not quite that high. I think we're doing a promotion, or at least 2 promotions every fortnight. The other thing to look at is the number of modules and the number of assets you have within Puppet. So just to go back, our assets basically double on a yearly basis now. Whether or not it's fully utilized is up to you to review and revoke licenses when they're not. So that's your internal process. But basically, we look at usage. If something's not used, we'll revoke a license within a week. The other thing to look at is patch levels. The reason I say that is your patch levels pre-Puppet were probably horrible. Post-Puppet, we found our patch levels to be within 6 months of the baseline. That's because people have more time to do other things now. And patching a fleet of 600 hosts is not easy. So we've written some stuff in MCO, which we're happy to share, for patching, for Red Hat and for Solaris. So, summary, small iterations. Keep it small, even for things that you think are big, break it down into smaller tasks. Keep your Puppet builds and your increments very, very small. The second lesson is, even if you think you have it right, you don't, because your needs will constantly change. So just suck it up, do it, and fix it later. It's never going to be perfect. It never will be. You'll have to accept that. Rework is okay. Don't yell at people for doing rework. It happens with progression, it happens with code, it happens with just about everything. The other issue is you're going to have a lot of problems. Don't try and solve them all at once. Pick one or two and then try and fix them. You also need to be very, very flexible on the way you solve your problems. So if you go back to this, dev, test, and prod in traditional architectures, this is really frowned upon. But we just dealt with it because we thought, look, what's the worst thing we can do, right? And we'll change it later. And we did change it later. You've got to make sure everybody also understands your workflow. The reason being, if people don't understand your workflow, they won't understand how to get things into prod, they won't understand your method, and they won't understand your lead times. Everybody has a cycle time. Workflow will define your cycle time.
That's a question about the previous slide.
Sure.
Did you say your patching is 6 months behind and it's better than where it was?
Yes, it was. So just to repeat the question, it was asked if our patching was far behind. Our patching was far behind, and our baseline is about 6 months. Now, yep.
Isn't that bad?
It depends on how you look at it. Solaris do quarterly updates, so we're in N-1.
Okay.
So we'll patch Solaris, which is our enterprise systems, at N-1. So the statement made isn't that bad. It's all contextual. Red Hat, we'll discuss it later because I've got a slide on it. With Shell Shock, we had patched within 8 hours of actual. I'm not talking about critical patches, I'm talking about the baseline, the quarterly vendor updates and that sort of stuff for the platforms. It was horrible before. We were like 18 months out before. Yeah, which is quite bad. So, last point, you've got to prepare for that guy. Every team has one of these people. If you don't, I've got a couple to lend you. It's basically the mistakes that people make as they're doing their routine stuff. The more you repeat something, the more blasé you become about something, the more likely you are to make a mistake. Puppet takes all that away. But it also gives that guy the ability to break all your stuff. So your workflow needs to consider the ability, rather consider the people, your lowest common denominator, and his ability to not break stuff. So you really have to consider what you have to do with this, this kind of power. The way we dealt with it, essentially separate dev, test, and prod. It removes all the bad effects, right? It also removes fear, which is a great thing. We also have sub-collectives. It took us a long time to get that working. Some of you who are new to Puppet, you won't understand terminology. But if you have time, spend some time looking at sub-collectives, it's really worth it. The other thing is your workflow. Publish your workflow and make sure everybody understands your workflow. I'll keep going on about it because for us, it is one of the most important things that we work with daily. And you also need to create an environment where shortcuts aren't the way to do things. What you should inherently do is create an environment where shortcuts take longer to perform than the actual change itself. Because that really breeds the culture of doing things right. There's nothing people hate more than hard work, right? So a couple of wins that we've had over the past year, and I'll take a couple of minutes on this slide again. We can go through questions as well. Shell Shock and Heartbleed, everybody was affected by that. Within about 8 hours of the patch being released, we'd had it all across the 600 systems. Solaris took a little bit longer because their patches weren't actually released, I think, for a couple of weeks. The other big thing that you have is consistency. All the UIDs, GIDs are all consistent across our host now because they're managed in Puppet. That's a huge deal. Like for us, managing that manually or through a script is completely untenable for 700 hosts. Complete inventory. So for those of you who work with auditors and whatnot, having a complete inventory and the ability to figure out who has access to what at any given time is a fantastic thing. We've actually also moved from Novell to AD Auth, and the change took us like 3 minutes, as opposed to maybe a week and a half. We also changed our DNS and NTP infrastructure. We've moved to info blocks from Unix servers. Also took us not very long, it was seconds. So my last point, dealing with the Auditor General's office. I used to hate doing this 18 months ago, 24 months ago. They used to come, just be a 300-page document, this is what you got to fix. Now, as soon as they come in, I'm just waiting for them to leave, because we have all the stuff ready for them to do. As soon as they come in, it's like, you got to get rid of these accounts. Before they finish the sentence, the people are gone, the accounts are gone. And also report on our patch levels. Basically, any compliance thing goes out the window. It will save you a lot of time. So for us, what's in progress at the moment, we're starting to use Hira. There are, I think, 3 nodes that we've customized for Hira. We're also looking at auto-signing certs for AWS. So be interested to speak to anybody who's doing that at the moment. If you are, just pop your hand up. Chat a bit later on. Now, I'll hand over to Nigel, who's going to talk to you about the application stuff.
Yes, excellent. So at RMIT, we didn't start using Puppet for application stuff until relatively recently. So our impetus was basically because for a very long time, other means of communication between teams at RMIT has all been about big Word documents with big tables full of IP addresses and usernames and passwords and blah, blah, blah. Now, this is terrible, as I'm sure all of you are aware. Where do you start? So, we needed some way of being able to specify what we wanted to do, what we wanted our infrastructure guys to do for us, in a consistent and repeatable way. So, again, as you can see, we don't want to document things for people because people screw things up. We all do it. These guys do it, I do it. It's always going to happen. In a way, what we really wanted to do was get rid of these guys entirely and replace them with a computer or a shell script or something. Because that way, all we have to do is write down what we need and write it down in an unambiguous format. It sounds just like Puppet, right? So the other thing we want to do is put everything into revision control, which we had very badly done with these big collections of Word documents. So, why Puppet? Well, we started off by trying to use Vagrant to build up proofs of concept so that we could actually prove that things worked before we wrote them down and asked the infrastructure guys to build them for us. Because I'm sure you've all come across that chicken and egg problem where you go, oh, I've got this thing, I want to do it. Can you build me a machine so I can install it so that we can find out how it works and if it works and how we need to install things? And the infrastructure guys come back and they say, sure, tell us what you need, how much disks it's going to use, how much IOs it's going to generate, how does it need to be configured? And the answer, of course, is, well, we don't know yet because we haven't installed it. We haven't even tried to install it. So that's where the Vagrant came in for us. And it just so happened that in the Vagrant Getting Started guide at that point, the instructions for Puppet were there before the instructions for Chef. So we just kind of went through and we did it, it worked, and that was great. We never actually got around to using Chef at all, which in retrospect is probably good. Now I've had a chance to look at it. I ended up talking to some of the guys in the Unix team over beers about what we were doing with Vagrant, and they said, "Oh, Puppet, yeah, we're doing that." And then, we thought that actually collaborating might be a good idea. So we ended up with everything that wanted to use Vagrant to have some kind of virtual dev environment that the developers could use before we bounced up off to infrastructure. Everything would have its own set of modules in its own source control repository. And we ended up rewriting let's fake this virtual machine to make it look like what these guys are going to give us, or look like what we think these guys are going to give us. And we got that wrong a little bit. So there's subtle differences between some of our virtual environments and some of our real environments, just due to that. And as a result, we have annoyances with that. So for our first steps, the idea was just get everything we possibly can in source control. Everything at all. If we hadn't had Puppet, we probably would have just ended up with a whole bunch of Word documents in source control. And thankfully, that's not what we ended up with. So in order to build one of these virtual machines, we use our normal build process. When we started, it was an application that was using Maven, but there's could have been whatever. And then Vagrant would build the virtual machines and use the Puppet apply provisioner. And that would just configure the VM, and then we'd do our normal scripted install of the actual application and run test cases. And that, as a set of first steps for us, was actually pretty good, because everything after build the application and installer used to be something that we had to get somebody else to do, had to get another team to do, and that could take weeks because they're busy. And at that point, they were in an entirely different building on the other side of the city. So it wasn't as though we could just walk around and say, "Hey guys, where's that thing that we wanted?" So just as a bit of as an aside, what we as an applications team wanted to do is a kind of a whole stack specification through code. So VM, the host OS install, the application, the load balancer that sits in front of the application, the firewall that sits between everything and everything else, DNS, and whatever other stuff that happens to be needed in terms of infrastructure configuration and application configuration. And we want to ultimately get all of this stuff into source control so that we can basically take a snapshot of whatever and rebuild it. Is anybody actually doing this? The whole lot, from top to bottom? Awesome, I'll talk to you later. So our question is, can we do all of this with Puppet? I don't know the answer to that yet. So for our next steps, which is basically, this is the last 3 months worth of stuff, is we put more stuff in Puppet. So rather than having our old, here's an installer that just does everything, we've got a generic kind of installer which will put pretty much everything that doesn't need configuration in. And then all of the actual configuration stuff will be done by Puppet. So server.xml in Tomcat that's serving an application, properties files that tell you, where your authentication server is in this particular application tier. All of that sort of stuff now is managed by Puppet. And after these guys complained a lot about the space we were taking up, we're no longer putting our installer samples in here. And now we're just fetching them from a staging server. When it's something we're building ourselves, we're actually starting to look at, why don't we just run this stuff from the repository straight onto where we're going to deploy it. Saves a lot of time. Or it might save a lot of time. We're not actually doing that, I don't think yet. The biggest problems we're having with this is some of the stuff that we deploy is not actually stuff that we develop. It's things like Jira or Stash. Things that are built by somebody else, we just install and configure it. We've currently got no good way of handling upgrades. Ideally, we'd like to be able to just get into the manifest and say, or in IRA, actually, for that matter, and say, in the dev tier, we want version 3.1. Press the button, have it go, see if it works. At the moment, we don't have a good solution to doing that. So, patching files after they've been deployed by an installer, rather than just blapping server.xml on the top, being able to say, hey, I just want to edit the port in the connector element of server.xml. Now I've had a look at ORGS and that's pretty good. It doesn't seem to work for everything. I don't know if that means we just need to go in and put some more lenses in, but we'll see. That's stuff we're going to be looking at in the next few months. And again, how do we configure the whole stack? And there's going to be some questions and answers about that, particularly when these guys roll up Puppet 4, I think. And once they've got their auto signing for AWS, I think we're going to have a chat with them about can we do auto signing for the virtual machines running on our desktops as well, so that we can get rid of that whole separation between the Puppet modules that are defined in the Vagrant and the Puppet modules that are defined in their Puppet master. And this is back to Ronnie, I think, because I don't remember writing this slide. Thanks, guys.
So I'm acutely aware of the fact that we're the guys before lunch, so I'll try and keep it to like 2 minutes. For us, continuous delivery, basically, we fell into it. It was an accident, but we like where we are now. We should be trying to get to here. The value that you get are basically, it's over the course of 18 months, we've seen a lot of value in consistency. We've had very few failures in prod. Speed to build up and tear down. It's incredibly fast with Puppet once you get your stuff done right. Once they get on board, it'll be even faster. You also give people the tools that they need to deliver faster. That is one of the most important things that you can ever give people. The ability to deliver as quick as they want to. If tomorrow night they want an environment, we can give them one exactly like dev test within 3 minutes. Right? That used to be a real problem, especially when we were building from Word docs. Everybody has their own build process. Puppet will build everything for you the same way all the time. You shouldn't lose sight of the value of consistency. The greatest thing for me as middle management was governance and auditability. That's two of the biggest nightmares that I have every 6 months. Data comes back, so-and-so comes back, what have you done about these problems? Now it's trackable. If I've made a change, it's in Git. I can show the changes, I can show that I'm reviewing accounts, patching, I'm applying updates. I'm also consistent, develop my environments. If I delete a person on one node, he's gone on all 700. That value is very high for me. So just, if you've got any questions, feel free to ask now. There's a couple of RMIT guys on the floor. Michelle's there, I see. Daniel, Adrian's there as well. Nigel, myself, just walk up to us, approach us. more than happy to have a chat either here or later on. Just a couple of points. The self-sign thing with AWS, if you've done it, I'd love to have a chat with you. If you've got an AWS presence with Puppet in there, I'd love to have a chat with you also. Question?
You guys moved to AWS, right? Are you using Puppet on that, or you are still in the process?
So the question was whether or not we're using Puppet in AWS. The answer is we've got an AWS presence at the moment, but it's minimal and it's not Puppet managed. The next part of the project is to deliver the AWS presence for Puppet. So that's the next phase, and then we're going to continue deploying apps in AWS.
So shouldn't we go with the production environment somewhat diverse in terms of operating system applications, etc.? So in your dev and test,
Yep.
how do you, what's your dev and test for 700 servers?
Okay. The question was about our diversity of our platforms and our footprint. So in practice, whenever we buy production hardware, we buy dev test for them as well. So in theory, about 2/3 of our fleet is dev test, about 1/3 is pro. Also with the M9000 and the Oracle stuff, it's easy to maintain because we have LDOMs and basically the equivalent of ESX on Oracle. We also have ESX, which makes moving stuff back and forth quite easy. I'm not sure if you're familiar you are with Red Hat satellite. So we have channels for satellite as well. That makes tier separation a lot easier. So our dev test pod tiers, and you subscribe to your channels and you push out updates depending on what channel you subscribe to. There's another question, yeah?
Yes, my question was actually around satellite. And are you using MCO to orchestrate your patching through a tool like satellite, or are you managing individual packages?
That's an excellent question. The question was around whether or not we use satellite in conjunction with M-Collective. Red Hat Satellite is basically a product that gives you an orchestration engine for your subscribers to Red Hat. Basically, when you build a machine, it subscribes to satellite, and you can say, there's 5 channels, you're a subscriber to 3 or 5 or whatever. We do use MCO to patch. Sometimes we use satellite itself when it's easier, but MCO is the majority of our hardware. What will happen is we'll push out our packages and updates through satellite and MCO. Yeah, I'm happy to have some of these things in details on how we do it if you like. Yep. No other questions? Cool. Thanks very much.